Want to consider an assignment problem. A company has 4 jobs to be done by 4 machines. The matrix below shows the cost of assigning each job. Find the optimal way to assign the jobs to the machine so as to minimize the total cost. So the J stands for the jobs, and these are the machines that we are using. And therefore, we want to find the best way to allocate. So we pick the lowest element or the smallest element in each row. So select smallest element in each row. And then we subtract for each one of them from that smallest element, that is J2, J3, and J4. So for the first one, the smallest is 5. So 6 minus 5 is 1, 5 minus 5 is 0, 14 minus 5 is 9, and 9 minus 5 is 4. The smallest is 6, 6 minus 6, 0, 3, and 4. And for the third one, the smallest is 3, that is 2, 0, 4, and 2. The smallest is 7, so it's 0, 1, 3, and 0. So what do we do that? So after doing that for the rows, and so that is for the rows, we need to do the same for the columns. Now, for this one, from the previous one, we take the smallest in each column and we subtract. So the smallest for the first column is 0, so it will remain as it was. It was 1, 0, and 2, 0. For this one, the smallest was 0, so it remains as 0. For the third one, the smallest is 3, so it is 6, 0, 1, and 0. And the fourth one, the smallest was 0, so the matrix remains as it is. After that, this is what we call the reduced matrix after doing the rows and the column operation. So we want to cover the zeros with the minimum number of lines, both horizontal and the vertical lines. So we have 3 lines, but 4 rows, stroke 4 columns. So since lines are less than rows stroke columns, then we say the solution is not optimal. So if the number of lines that we have drawn were equal to the number of rows or the number of columns, then we would have said that the solution is optimal. But since that is not the case, what we do next is we get the smallest element. So we find smallest element. So that's what we want to do. And then we are going to subtract the values that have not been crossed over by the lines. So that's what we'll start off by putting down the values that are covered by a line. And from there, so we put down all the values that are covered by a line. Now the ones that are not covered by a line, the smallest element is 1. So 1 minus 1 is 0. 6 minus 1 is 5. 4 minus 1 is 3. 2 minus 1 is 1. 1 minus 0. 1 minus 1 is 0. And 2 minus 1 is 1. Then again, we try to cover with the minimum number of lines, both horizontal and vertical lines. So in this case, we have 4 lines, which is equals to rows or columns. Thus, solution is optimal. And therefore, we want to allocate based on the values that we are given. The zeros are the ones that we want to use for allocating our matrix. We allocate where there is a 0 to, for example, what we mean by that is that machine 4 can do job number 1, number 3, and number 4. Machine 1 can do job number 1 and 2. Machine 3 can do job number 2 and 3. So it looks like it's only machine 4 that can only do job number 4. So I'm going to put a box there, because there is no other machine that has a 0 on job number 4. So that is taken care of. Now, looking at the smallest value, machine 2 and 3 can do job number 3. And also, machine 3 can do job number 2. And since job number 2 has the smallest value of 3 from the original matrix, this was a 3, and this was a 7, then that I could assign machine 3 to job number 2. So job number 2 and job number 4 have been taken up. So machine 1 can only do job number 1 because it could only do 1 and 2. And therefore, machine 2 can do job number 3. And if machine 2 can do job number 3, this was 9 and this was 6. And therefore, the minimum total cost is just the sum of those values that we have there. So total cost will be equals to 6 plus 3 plus 9 plus 7, which is equals to 25. Now, would it have been different if I allocated them differently? Possibly. Maybe if I still allocated this job here as 7, and then I could have allocated it here, and at that point the value is 7. Then I allocate this here, the value is 6. Then this would have been slightly higher because it would be a 7 plus 7, 14 plus 6, 20. That would have given me 26, which would have exceeded. So the best allocation would be 25.